Imagine for a second that you have a personal assistant.
Okay, I'm picturing it.
But we aren't talking about like a standard assistant who just sits at a desk waiting for you to hand them a to-do list. I want you to imagine someone who intimately understands your overarching goals, watches the trajectory of your current project, and, well, has already completely finished the prep work for the next 3 things you're going to ask for.
Oh, wow. Before you even ask.
Exactly. Before you even open your mouth, you walk into your workspace, and the necessary files are already open, the background research is compiled, and the drafting templates are loaded.
That sounds like magic, honestly.
Right. All you have to do is nod and say go. And that is exactly the kind of operational leap we are looking at today. Welcome to this deep dive.
Yeah, it's a really exciting topic we've got today.
It really is. Today, we are unpacking the Orion Collective System's Meta Playbook v2.0. Specifically, we're focusing on its new predictive mode.
Which is a huge deal.
Yeah, based on the sources we've been reviewing, this is a fundamental shift in how artificial intelligence operates within complex workflows. We are moving from AI as a reactive tool, something that sits dormant until you command it, to an anticipatory execution layer.
Saving massive amounts of time.
Exactly. Saving time and boosting efficiency in a way that feels completely seamless. Okay, let's unpack this. Because to truly grasp why predictive mode is such a paradigm shift, we have to look closely at the baseline.
Yeah, we really need to understand the environment it's evolving from. That is definitely the best place to start.
Right.
To appreciate the magnitude of this update, you really have to look at the system's standard operational matrix. The Orion Collective handles planning and execution through a few different modes. You have your strict and creative modes, which, well, they do exactly what they sound like.
Sure.
But the absolute workhorses for most users are fluid mode and swarm mode. Let's break down how those function. So fluid mode is your highly adaptive reactive state. Think of it like a seasoned improv actor. It waits for your prompt, and then it generates on-demand micro-iterations. It's fantastic for general exploration because it balances speed and control without requiring much computational pre-work.
But it's waiting on you.
Exactly. The defining characteristic is that it's entirely dependent on your input. It does absolutely nothing until you speak.
Right, so it's highly capable, but essentially just sitting in standby mode.
Yeah, exactly. Then on the other end of the spectrum, you have swarm mode. This is where the system gets highly parallelized. It's specifically designed for complex, multi-track objectives.
So lots of things happening at once.
Right. Imagine a scenario where you have a dozen specialized AI agents working independently at the exact same time to solve different pieces of a puzzle.
Sounds chaotic.
It can be, but it's incredibly powerful. But it comes with a specific bottleneck, which is coordination overhead.
Okay, what does that mean?
Every time you issue a complex command in swarm mode, the system has to wake up those agents, give them their specific context, align their objectives, and manage the event-driven callbacks so they don't, overwrite each other's work.
Oh, I see.
It's like a specialized construction crew. I mean, they can build a house in a day, but they still need to stand around the site for 20 minutes while the foreman hands out the blueprints. They are fundamentally input-driven and reaction-bound.
So if I'm translating this to everyday workflow, fluid mode is great for quick isolated tasks, but it's always waiting on me.
Yeah.
And swarm mode brings the heavy machinery, but I have to pay a time penalty while the crew gets organized. Sort of like a flash mob waiting for a text message to start dancing.
I love that analogy. You've hit on the exact friction points. And that brings us to predictive mode, which completely shatters that reactive paradigm.
Because it doesn't wait.
Exactly. Predictive mode does not wait. Instead, the system looks 1 to 3 steps ahead into the future of your workflow. It continuously runs internal simulations based on your current trajectory and your past behaviors.
So instead of a chess grandmaster running simulations, which honestly is how everyone always describes AI, it feels more like an elite air traffic controller.
Oh, that's a good way to put it.
Right, like someone who has already rerouted your connecting flights and updated the gate assignments because they saw a weather pattern forming 3 states away.
And all before you even printed your boarding pass. I like that analogy much better because it captures the logistical rerouting happening in the background. Yeah. The output of those internal simulations is highly structured. The system automatically generates what the documentation calls probable PTAS variants.
PTAS. Okay, what is that?
PTAS stands for Purified Task Agnostic Steps. What that means is the system looks at where you are heading, forecasts the next logical tasks, strips out any domain-specific biases or formatting quirks, and creates pure executable logic steps. Because the system is forecasting and building these steps before you even ask for them, it achieves a state called zero-latency pipeline readiness.
Zero-latency pipeline readiness. So essentially, eliminating the loading bar entirely.
Completely.
The data pipe is already pressurized and full of the necessary materials.
That's the core of it. When you finally do issue your next command, the system doesn't have to initialize anything. The foundational logic is already built and waiting for you.
That's incredible.
The internal testing data from the sources indicates that by operating in this time-compressed environment, literally running one full objective ahead of the user at all times, the system can compress total execution time by roughly 40%.
40%. A 40% reduction in waiting time is a massive gain, especially when you compound that across an 8-hour workday.
It really is.
But I have to push back here.
Sure.
Because this immediately raises a glaring red flag for me. If the system is constantly running out ahead of me, guessing my next 3 moves, what happens when it guesses wrong?
That's the million-dollar question.
Or, more concerningly, what happens if it predicts a path that violates system constraints or project rules? If it's building the road in the dark, ahead of my headlights, how do I know it's a safe road to drive on?
It's the most critical question to ask, really. And the architects of the Meta Playbook built the entire architecture around mitigating that exact risk.
Okay, how?
Well, the true engineering feat of predictive mode isn't just the forecasting. It's the invisible safety nets running concurrently. The system relies on 2 massive technical safeguards: proactive refinement loops and preemptive integrity scans.
Let's tackle the refinement loops first.
Okay, so predictive mode operates on incredibly strict confidence thresholds. If the system's internal confidence in a forecasted PTAS path drops below 95%, it doesn't prompt you for clarification.
Wait, it doesn't ask me.
Nope. Instead, it automatically inserts invisible micro-iteration cycles.
Wait, how does an invisible micro-iteration cycle actually work? Is it just guessing again?
Not exactly. It takes the raw predicted task and loops it back through a dedicated purification agent known as PTAS.
PTAS.
Yeah, and this agent's sole job is to clean up and refine logic. The system will continuously run the predicted task through PTAS, tightening the parameters, checking the logic, and reshaping the step until it crosses that 95% purity threshold.
And I don't see any of this.
Exactly. It does all of this computational drafting and trashing in the background without you ever seeing the messy middle.
Okay, so it's doing its own rough drafts, realizing they aren't up to standard, and throwing them in the bin before I ever even look at the desk.
That's a great way to look at it.
I like that. But what about the integrity scans? You mentioned project rules and constraints.
Right, because the refinement loop just ensures the task is logically sound. The preemptive integrity scans ensure the task is structurally and operationally safe.
Okay.
Before any actual execution command, which the system designates as a /cmd/exec, is allowed to fire on one of these predicted paths, the system runs continuous silent background checks using 2 specific agents.
Who are they?
First, an agent called DEMA checks for parameter compliance. Second, an agent called system monitor checks for structural integrity. These 2 are constantly scanning the what-if simulations in real time.
And if they find something bad?
If they detect any risk, they immediately issue a halt trigger.
Okay, I have to stop you there because silent background checks and halt triggers sound a lot like an automated filter.
I know where you're going with this.
Automated filters are notoriously flawed. Doesn't adding a silent, invisible filter just mean the AI is secretly censoring my workflows or deciding what I can and can't do without actually telling me?
It's a very valid concern, but it really helps to understand what DEMA and System Monitor are actually measuring. They aren't subjective sensors.
Okay, what are they then?
They are checking against hard operational bounds and project parameters. For instance, System Monitor is looking at the back-end infrastructure. It asks, if the user takes this predicted path and requests a massive data scrape, do we have the server allocation for that, or will it crash the workspace?
Oh, I see.
Right. And DEMA is looking at the predefined project rules. Like, does this predicted data routing step violate the privacy tags we established in the root directory?
So it's more about logistics and safety.
Exactly. They're scoring resource risks and structural conflicts on a weighted scale. And crucially, the halt is issued on the prediction, not your execution.
Ah, I see. So if the prediction is risky, it just throws out the prediction.
Yes.
It's not blocking me from doing it if I really want to. It just refuses to pre-build a dangerous road.
Precisely. It preempts the risk entirely. So when you actually do hit enter and request an action, the only predictive options waiting for you are pre-validated, compliant, and structurally sound.
I'm sold on this ACNS.
Yeah.
But, there is no such thing as a free lunch in software architecture.
Definitely not.
You don't get a 40% speed boost, constant invisible rough drafts, and rigorous background system checks for nothing.
Yeah.
What is the actual cost here? What is the trade-off for running this?
You're paying in raw compute power.
Ah, of course.
Yeah. If we look back at the operational matrix, fluid mode is incredibly lightweight. It burns very little energy because it does zero pre-work.
Right.
Swarm mode trades compute power to manage that heavy coordination overhead we talked about, but predictive mode requires a significantly higher continuous compute load.
Because it's always thinking.
Yes. To maintain this environment, the system is constantly burning processing power to run anticipatory variants, simulate those future workflows, run PTAS refinement loops, and execute continuous DEMA and system monitor scans.
On paths I might never even use.
Exactly, on paths that you might never even click on.
So you are basically leaving the engine revving at high RPMs all day, just in case you want to launch off the starting line.
That's a really great way to put it. It is the literal cost of foresight.
Yeah.
You are trading system resources and compute budget to completely eliminate human waiting time.
Which honestly, for most organizations, is a trade they will happily make. Compute is cheap. Human focus is expensive.
Yeah, true.
Now, this brings up another mechanical question. We know the brain of the system is working overtime calculating all these possible futures, but the Orion Collective System is a swarm of highly specialized agents.
Right.
How does the rest of the body know what to do with all this predictive data?
That requires diving a bit into how these agents communicate. Have you ever looked into the internal communication framework the system uses?
You mean kicklang?
Yeah, exactly.
I've seen it referenced in the documentation, but for the listener who might not be deep in the back-end developer notes, what exactly is kicklang and why does it matter here?
I'm really glad you brought that up. Kicklang is essentially the proprietary internal orchestration language that all these specialized agents use to talk to each other.
Like their own native language.
Right. It's how they pass variables, context, and commands back and forth. In a reactive system, kicklang is used to say, hey, I need you to do this now. But in predictive mode, the forecasted horizon data is actively broadcast across the kicklang framework to the individual agents before you even issue a command. It gives the agents time to adapt.
How so? Give me an example of an agent adapting.
Let's look at the orchestrator agent. Its job is holistic oversight of the swarm.
Like a manager.
Exactly. In predictive mode, the orchestrator looks at the forecasted pipeline data coming through kicklang and dynamically spawns new roles or auto-adjusts operational modes based on what is approaching.
Wait, how does it dynamically spawn a role?
So based on the PTAS variance, the purified steps we discussed, the orchestrator can see, for example, that the next likely step involves heavy statistical analysis.
Okay.
It will preemptively allocate memory, spin up an instance of a data analysis agent, load the current project context into that agent's memory bank, and put it on standby.
Wow. It is essentially hiring and onboarding new staff for a project before the client even signs the contract.
Exactly. And then you have an agent like Webplan, which generates strategic blueprints.
Right.
In a normal reactive mode, Webplan starts with a blank page when you ask for a plan. But in predictive mode, Webplan receives pre-built spec templates from the orchestrator based on the forecasts.
So it's already got the outline.
Yes. The second you ask for the plan, Webplan just populates the template. It completely skips the structural drafting phase.
Okay, but all of this, the kicklang broadcasts, the orchestrator spinning up agents, Webplan grabbing templates, this is all happening invisibly in the back-end code.
Right.
If I am a project manager using this system, or if a team is collaborating within this swarm, how do we actually see this complex predictive data? I can't just stare at a command line all day hoping the AI knows what it's doing.
No, of course not. And the user interface is actually one of the most sophisticated parts of this update. The system relies on a specialized agent named AR00L.
AR00L.
Yeah, and its entire function is handling visual assets and logic visualization. Just like Webplan preloads drafting templates, AR00L preloads visual hooks and queues up matrix visualization templates based on the predictive horizon.
Okay, so it pre-draws the map.
Exactly. When the system shifts into a hybrid mode, which is where it blends predictive forecasting with swarm execution and fluid adaptability AR00L, renders a unified visual layer for the team.
Describe that for me. What does this visual layer actually look like if I'm sitting at my monitor?
Think of it like an augmented reality overlay resting on top of your workflow dashboard. It uses a very intuitive system of color-coded synergy zones so human operators can instantly grasp the state of the swarm without reading a single log file.
Okay, what do the colors mean?
Green zones indicate stable predictive paths. If you see green, the system is highly confident in its forecasts and the pipeline is fully prepped.
Makes sense.
Yellow zones indicate fluid injection points. This tells the human operator, hey, the system anticipates high volatility here, so be ready to provide manual input or adapt on the fly.
Got it.
And blue zones represent swarm parallel tracks. This visually shows you which tasks have been chunked out and are currently being processed simultaneously by multiple agents.
That is genuinely brilliant. You aren't digging through back-end logs.
Yeah.
You are looking at a living, color-coded map of your future workflow.
Exactly.
Green means the system has this, yellow means I need to be ready to steer, and blue means we are currently dividing and conquering.
It creates total transparency. And this visual layer is crucial because predictive mode is often used as a preparatory overlay to transition into other modes.
Okay, you mentioned avoiding mode lock failures when switching gears earlier in the documentation. I need to see how that actually plays out in practice.
Sure.
If I am a user and I ask for a complex task right now, how does the system ensure all these agents don't just trip over each other during that transition from predictive into swarm?
Let's ground this in a concrete example from the source material. It's referred to as the webplan PTAS-based plan scenario. Let's break down exactly what happens, microsecond by microsecond.
Let's do it.
Okay, so the user's high-level objective is activate webplan to generate a strategic, tailored plan grounded in a fresh PTAS extraction.
In plain English, make me a clean, task-agnostic project plan.
Exactly, the objective is set. Now, because predictive mode is active, the pregame has already happened. Let's say 500 milliseconds before the user even fully registered that command in the execution layer, the system's anticipatory forecasting recognized the trajectory.
It saw it coming.
It did. It already queued up 2 probable plan variants, one linear and one optimized for a swarm. So, the user hits enter, the execution begins. The system fires the command to activate an agent called PTAS, the extractor.
And what does PTAS actually do in this exact moment?
It takes the user's messy human language objective and breaks it down into raw, task-agnostic steps. For example, if the goal was launch a marketing campaign for the new shoe, PTAS extracts pure steps, like analyze demographic data, identify core messaging, draft copy.
Okay.
But remember, because it's using the preloaded predictive data, this extraction happens almost instantly. Immediately after, PTAS, the purifier agent, catches those raw steps.
Ah, this is where that 95% threshold comes in.
Yes, exactly. PTAS refines those steps. And because DEMA and System Monitor have already been running those silent predictive purity scans in the background, checking server loads and project parameters, PTAS's refinement hits that 95% confidence threshold on the very first pass.
Wow. So the rough drafts were already thrown away yesterday.
Right.
The raw materials are extracted and perfectly purified without a single error because the safety inspectors had already cleared the site.
Exactly. Now we hit the synthesis phase. The perfectly purified steps are handed off to Webplan. Webplan grabs those pre-built templates the orchestrator prepared and instantly outputs a TAS-grounded strategic execution blueprint.
Okay, so the plan is made.
Yes. And here's the really clever part. Because of the predictive foresight, Webplan doesn't just output a static text document. The blueprint comes embedded with swarm coordination hooks.
Swarm coordination hooks. You mean it's already bridging the gap to the next phase?
Yes. The system knows that executing this plan will require swarm mode. So the blueprint includes pre-aligned instructions for all the agents that will be needed.
Skipping the bottleneck.
Exactly. It avoids the coordination bottleneck entirely. The orchestrator broadcasts what are called forward-looking sync packets through kicklang. Every node in the swarm is pre-aligned. They already know the mode switch is coming, which completely avoids any mode lock failures or stuttering in the workflow.
That is wild. It's writing the plan, but it's also simultaneously handing out walkie-talkies and assignments to the team so they can hit the ground running the second the plan is published.
Yeah. And the final result of all this, AR00L already has the visual matrices generated. The dashboard updates instantly with those green, yellow, and blue synergy zones. The entire comprehensive blueprint is delivered to the user
In real time.
in fractions of a second. All of this happens seamlessly because the friction of calculation, the heavy lifting, was already handled in the predictive horizon.
I want to try and visualize this for anyone listening who has ever managed a complex project.
Go for it.
Imagine walking into your kitchen because you suddenly decided you want to cook dinner. But when you walk in, the ingredients are already chopped. They're already measured into little prep bowls. The pans are on the stove, and the oven is preheated to the exact temperature.
I'd cook a lot more if that were the case.
Right. Why is it like this?
Because the kitchen noticed you had been looking at Italian recipes earlier in the day, checked your pantry inventory to see what was viable, and ran a simulation of the two most likely dishes you were going to make.
Exactly.
All you have to do is turn on the burner. That is exactly what predictive mode is doing for knowledge work.
That kitchen analogy perfectly captures the user experience. It completely removes the friction of initialization and setup from the human operator. By utilizing internal simulations, preemptive parameter scans, and forward-looking kick-line synchronization, the Orion Collective System isn't just reacting faster. It is fundamentally operating one full objective ahead of you.
So if you're listening to this and wondering how this applies to your own daily workflow, think about how much of your day is spent just waiting.
A lot of it. Waiting for a script to run, waiting for a team to align, waiting for an initial draft to be generated so you can finally start editing. We are moving past the era of the chatbot, where you type a prompt and wait for a response.
Yeah, that's the old way.
Predictive mode shows us a future where AI is an anticipatory layer wrapping around your entire workflow. When the system already has the purified steps, the parameter sign-offs, and the color-coded visual dashboards preloaded, your job shifts. You are no longer managing the micro steps. Your only job is to steer the high-level intent.
To take that a step further, it leaves us with a truly fascinating dynamic to consider.
What's that?
Well, the system achieves this massive 40% time compression by teeing up the 1 to 3 most probable paths. It pre-builds the easiest, most frictionless roads for you to walk down.
Right.
But if an intelligence is constantly preparing the perfect frictionless path forward, at what point does the system stop predicting your goals and subtly start shaping them, simply because its pre-built paths are just too convenient for you to ignore?
Oh, wow. That is a thought to let linger. Thank you for joining us on this deep dive into the Meta Playbook v2.0. Keep questioning the tools you use, keep exploring the future of intelligent workflows, and we'll catch you on the next one.